Now in question number 17, a student has three cards with numbers on them. Their sum is 782. Unfortunately, a worm at part of each card. What is the sum of the three missing digits? So at first, let's write all the digits here with their missing numbers. So we have two missing number here and then a three. Then we have one missing number here and four, and we have 4, 1, and missing number here. So if we add all of these three numbers, we will obtain 782. So here we have 3 plus 4 is equal to 7. So what is the number that if we write here, we will obtain here in this part 2? So we will need 5 here. And if you added this 5 with this 7, we will obtain 12. So we will have 1 here. So now we have 1 here and 1 here. And if we add these two to another number, two numbers here and here, we will obtain 8. So the sum of these two numbers here and here will be 6. So 6 plus 5 is equal to 11. And this is the required, and this is the correct answer. Okay, now in question number 18, Bushra weighs some blocks. How much do the three different blocks weigh together in grams? So at first we have here a rectangle and a circle. Here we have a triangle and a circle, and here we have a rectangle and a triangle. So here we have 200 gram, and here we have 100 gram, and here we have 240 gram. So as we notice, we have here two rectangles, and we have two circles, and we have two triangles. So if we add these two rectangles with two circles with two triangles, we will obtain 200 plus 100 plus 240 equal to 540. So 540 gram is the weight of these 6 items together. So but we need the weight of just only one rectangle and one triangle and one circle. So we will divide this 540 by 2, and we will obtain 270. So A is the correct answer. Okay, now in question number 19, there are 60 pupils on a trip. When they line up, the colors of their reflective vests follow the pattern yellow, green, and the colors of their backpack follows a different pattern, red, brown, orange, red, brown, orange. How many pupils with a yellow reflective vest also have an orange backpack? Okay, first of all, because we don't have only one we have only one pen in the exam, so we will use the letters and the numbers instead of the colors. So I will call here the yellow and green as yellow is 1 and green is 2. And for the colors here of the backpack, I will call this one is red, R, and this one is B, and this one is O. So if we put here 6 students, so 6 students, yes. So yellow, green, yellow, green, yellow, green, okay, 6. And we put this pattern of the color of the backpack. So you will have here R, B, O, R, B, O. So what are we going to look at? The student who with a yellow reflective vest, yellow, which is 1, and an orange backpack. So we will search for yellow and orange. So this one here. So as we can notice here, in each 6 students, we have only one student with a yellow reflective vest and an orange backpack. So in 60 students, we will have 10 students. So E is the correct answer. Okay, now in question number 20, in the following calculations, the same digits are hidden under the same figures. Different digits are hidden under different figures. So we have these equations. What is the value of this equation here? So at first, let's notice some important things. So at first we have one digit number here with one digit number here. If we add these two numbers, we will obtain two digit number. So we can notice that if we added the biggest one digit number, which is 9 plus 9, so the biggest number that we will obtain, the decimal point here, the decimal digit here, the tens digit will be 1. We will not have 20. So no, we don't have any one digit number. If we add it with another one digit number, so can we obtain 20 or bigger than 20? So the biggest number that we can gain here is 18 or 19. So we obtain the value of the first figure, which is 1. So all the squares here is 1 or 1. And now to calculate the value of the second figure and the third figure here, the triangle and the circle, we will notice something here. We have two numbers, two equal numbers. If we add them, we will obtain a circle here with 1. So if we added two same numbers, either they are even numbers or an odd numbers, so we will obtain an even number. So this circle must be an even number. So we will search for two numbers. If we added them, we will obtain 11. So if we, for example, give the circle 6 as an even number, so the triangle must be here 5. So 6 plus 5 is 11, but let's try here if this condition will be satisfied. So 5 plus 5 is not equal to 16. So this one is not the correct answer. So we have now to search for another two numbers that we can add them to each other and obtain 11. So we have 4 and 7. So if we give this one 4 and this one is 7, so 4 plus 7 is 11. Now if you put here 7 plus 7 equal to 14. So this is correct. So the values of the rectangle and the circle and the square are known now. So this one is 7, this one is 4, and this one is 1. So if we multiply these three numbers, we will obtain 28, and D is the correct answer. Now in question number 21, there are exactly two frogs in each row and in each column. The frogs decide that two of them will jump to a neighboring empty cell at the same time. Neighboring cells have a site in common. After that, there still are exactly two frogs in each row and in each column. In how many ways can the frogs do this? Okay, first we have in each row two frogs, and in each column we have two frogs. So for example, this one can move to this place and to this place, and this one can move to this place, and this one can move to this place and to this place. This one can move to this place, and this one can move to this place, and this one can move to this place. Okay, so first of all, let's study that the frogs only will move horizontally. So for example, this frog here and this one here. So this one will go to this place and this one will go opposite way to this place. So we will still have now two frogs in each column and in each row. So this is the first possibility. Now let's look at the second possibility. We have this one will go to here, to this place, will move to this place, and this one he will move to this place here, it will move to this place here. So this is the second possibility. Now let's look at the vertical movement. Okay, now in the vertical movement we have this one that can go to this place here, and this one that can go to this place here, and we have also this frog here can go up here, and this one can go down. So in general, we have 4 different possibilities for doing and solving this question. So D is the correct answer. Okay, now in question number 22, the figure below shows a beehive with 9 cells. There is honey in some cells. The number in each cell shows how many neighboring cells contain honey. Neighboring cells have a side in common. How many cells contain honey? Okay, so if we look first at this cell here, this one, it contains the number 2, so two of its neighboring cells contain honey, so this one and this one must contain honey, so I will put a circle here around each one of them. Now if I look at this one here, 3 of its neighboring cells should contain honey, but here we cannot know which cells are the that contain honey, so we will go to this cell here. In this cell has 3 neighboring cells, and all of them should contain honey, so this one should contain honey and this one should contain honey. Okay, now if we look at this one here, at this cell, 1 is written, and this cell has 4 neighboring cells, and one of them contains honey, so the rest will not contain honey. And now if we look at this cell here, and 2 of its neighboring cells should contain honey, so this one is correct. Now if we look at this 4 here, it has 4 neighboring cells, so this one and this one should contain honey. So now we completed all the beehive. If we count the cells that contain honey, we will obtain 1, 2, 3, 4, 5, and 6. 6 cells contains honey, and C is the correct answer. Okay, now in question number 23, 3 girls go to the tray as in the figure, one after the other, and take some cookies. One of the girls take all the hearts available on the tray. Another girl takes all the white cookies available on the tray. Another girl takes all the large cookies available on the tray. However, they don't necessarily take the cookies in this order. One girl takes 3 cookies, one takes 6 cookies, and one takes 7 cookies. Which of the following sets of cookies does one of these girls take? Okay, so first of all, let's see in this tray, let's look at 7 cookies from the same shape or color or size. So if we look at 7 hearts, we will not find 7 hearts in the same size. But if we look at 7 big cookies, we will find that these 7 here are big cookies. So if we assume that the first one that took the 7 cookies here took also the large cookies, so the 7 cookies are the 7 large cookies. And now if we go and see the 6 cookies, now we have a girl that take 6 cookies. So if we count here the hearts, the small hearts here, 1, 2, 3, 4, 5, 6. So 6 hearts here are taken by the girl that took 6 cookies. Now the last girl will take 3 cookies, 3 white cookies. So yeah, we have 3 white cookies here. So the last girl will take this white cookies, and now we have 3 sets of cookies. This is the first one, this is the second one, and this is the third one. So, and the question is telling us which one of the following set of the cookies does one of these girls take. And if we compare the answers with our sets, we will notice that E is the correct answer. Okay, now in the last question, question number 24, there are 2 types of a block. We have the white block here and the red block here. So a small cube can be made of 4 white blocks or 1 white and 1 red block. The larger cube shown here, this one here, showing the picture, is made of small cubes, 8 cubes exactly. So what is the smallest number of the white block needed to make the large cube? Okay, we will look at the cubes here one by one, the small cubes, and see how many white blocks do they contain. Okay, so here for this one, this cube here, so we have 1 red block, so we need 1 white to continue this cube. So here we have 1. In here we have this X sign, so we have 4 blocks, 4 white blocks, and here we have also 4 white blocks. In this cube, we have a red block, so here we need one white block. And here we have also one red, so we will need one. And here we have one white, so let's assume this is white and red. So here we have one, and also here we have one, because this white is appearing here, but we can assume that the other block is red. So here we have also one, and we have extra cube hidden under this one here or behind this one here. So in that cube also you will assume that we have one. So now if we sum all of these numbers here, we will obtain the number of blue blocks. So here, so we have two fours here, 4 plus 4, and we have how many ones? 1, 2, 3, 4, 5, 6. So plus 6 multiplied by 1. So we have 14 in general, so in total, and D is the correct answer. And by solving this question, we've come to the end of this exam. See you in the next videos.